Thank you. Thanks a lot, Pankaj. We'll try to project our voice. Not sure these are working, but
They are.
okay.
Yeah, we're good.
So our discussion is around AI application use cases across the value chain, and we have a terrific panel to help us really understand what is happening in the bowels of the AI movement, and perhaps get some insights that you can apply to your own domain and strategy. So as you know, I mean, AI has been there for a lot of years. Anybody who has done a computer science degree or electrical engineering degree probably has done some form of neural networks or expert systems in the, way back when. And but the Gen AI moment just changed everything in terms of really accelerating how we think about data, how we think about applying AI principles, ML principles to basic problems that are in front of us. I would like each of the panelists to just briefly describe their role in the organization and perhaps comment on kind of one big thing that they are working on as it comes related to AI and the transformation they might have seen. Why don't you get started?
Can you guys hear me? Okay, great. So my name is Arjun Bansal, and I'm CEO and co-founder of a company called Log10. We're a startup that's about 1 year old, and we just announced a fundraise of a seed round of $7.2 million. And this is my third AI startup in San Diego, so it's really great to see so much interest. I was at this event 4.5 years ago, and it was much smaller, so really, really great to be here. And then in terms of what we're focused on and what we're seeing is the, people talked about even in the previous panel about this issue of hallucinations and accuracy issues with using large language models and AI models. And so I've seen this kind of happen multiple times in the time that I've spent in AI, that there's a lot of hype, and then the promise, the applications don't catch up with the promise. And so with Log10, we're really focused on helping companies measure and improve the accuracy of the AI applications that they're building. And we've built a technology platform that empowers companies to have a handle on how well their applications are doing in production and then improve them over time.
Great, thank you. Andrea Yoder-Clark, I sit within the Google Accenture business group. I'm one of our global data and AI leads there. You know, most of you have probably heard of Accenture. We're one of the largest technology services companies in the world. What we primarily do, I mean, it's probably all of it, to be honest, but where we sit, working with many of the largest companies, we're seeing primarily trends, to your point, in accuracy, right? But also security. And then also looking at how do you really implement AI and Gen AI transformations that generate actual ROI and efficiency that you can measure for the organization. So we really work with organizations to scale that across the value chain within the company, everything from their underlying tech stack to understanding model choice to thinking about how they might deploy that to answer business questions and measure the results of that.
Ali?
More of that, thank you. Hi everyone, Ali Arsanjani. I lead AI/ML partner engineering for Google Cloud. And you may not know Google, it's a very small company. We started out in 2015 with building what's called Word2Vec. That was the turning point in the industry of converting numbers, or rather converting text into numbers. And then in 2017, we invented the transformer architecture, which the rising tide raises all ships. That was the beginning of the natural language processing and generation revolution, which we now call generative AI, because it's part of the generative aspect of natural language processing, understanding, and generation. And one of the most recent research, so we have a platform which can support our partners and customers across their journey from data to predictive AI to generative AI, and understand at each level of maturity, by the way, if you want to Google the maturity model, you can Google my last name and maturity model. There's an article on this. You can read this in detail. So at each level of maturity, you'll have certain things that you need in order to get to that next level of maturity. You can rely on the Google Cloud Platform to supply those characteristics as you go across that journey. One of the key things I'll say about the whole discussion around precision, hallucination, steering, punting, etc., around language models is that we recently conducted, actually at DeepMind, our research arm, but also, I'm not going to quote DeepMind because you'll say, hey, that's Google. But I'll quote Stanford, which is an independent body. So there's a recent, in addition to the work we've done at DeepMind, a Stanford University, very recent paper indicates that the reason behind hallucinations and fine-tuning. So our perception has been that if you take a new data set and fine-tune a model in a certain aspect of healthcare, that model is going to perform well because it's fine-tuned for that aspect of healthcare. Sounds obvious. We've been trained to think so. And in the courses that I teach in master's program in machine learning, that's what we used to teach. Hey, you take the model, you create a cleansed data set, labeled data set, now your model performs better in that particular task. Actually, what we're seeing is that if there's a dichotomy between the pre-training, so think of it this way, is if a kid has grown up all the time believing certain things, and now when they're 20, you tell them, no. All of what we taught you was not quite correct. Here's the reality. They're going to have a visceral reaction to that. They're not going to buy that. That's exactly what the language models do. So what happens is when you introduce the language models, these new fine-tuned things, they're going to say, if it differs from my pre-training data, it's going to hallucinate. So the research we've done, and Stanford as well, is that hallucination arises as a result of that discrepancy. So what do? So we've provided the industry's largest context windows, 1 million and now 2 million context windows, so you can put up to, let's say, 1,400 words into it. I'm sorry. 2 million tokens, or 1 million tokens is about 700,000 words.
We'll get into the details of it.
Yeah. So just to kind of conclude the thought there, once you utilize the large context for in-context learning, you can avoid a lot of the hallucination. That's where I wanted to get to, because it's so important. I know I've taken up time in the introduction, but I didn't want to miss the topic.
Thank you, Ali. That was amazing. So yeah, my name is Nitesh Banga. I'm the president and CEO of GlobalLogic. We are a fully owned subsidiary of the Hitachi Group. We also sit within the tech services spectrum as a business, but we focus primarily on designing and engineering next generation digital products, platforms, and services. All the way from the car that you drive, it's in-car engineering, the ADAS, infotainment, and life-saving medtech devices, whether it's diabetes pumps or sleep apnea devices and so on. So we actually engineer these kind of digital products for our clients. And I think to Chetan's question, right, like what excites me about what's going on right now is that AI has always been supporting automation for many, many years. It's always about mimicking a human action or collaborating with that. But this is the first time when it's starting to create. And I think when it starts to create, it actually opens a whole lot of possibilities, right? We've been talking about digital twins for so long. They've not really become a reality because of, the possibility of AI to create was not there. Or, for example, RPA. Some of those RPA experiments have not really succeeded because, you don't have the AI powering up, the regular automation. So I think the power of creation that has come to our hands is really what will unlock the next set of use cases, according to me.
Great, thanks. So maybe we could start by kind of sharing your thoughts on how your own processes have changed as a result of AI. Clearly, you are helping the layer above and your customers, but how has it impacted your own processes in product development, research, and getting your services out in the market? And so maybe we can start with Nitesh.
Thank you. No, I think that's a great question. So look, as I said, we are into the business of developing software products. or digital products. If you were to say no product is only a software product anymore, it's a hybrid, it's an embedded product. So I think just software development lifecycle per se is going through a big transformation right now, and we are applying Gen AI into our core software development practices, all the way from elicitation to engineering to testing and so on. So I think that has given us significant amount of power, significant amount of speed. But the interesting bit that we have observed here is that it's different levels of productivity improvement in different parts of the life cycle, and also how well you're trained. We did almost 60 cohorts already with our developers, and what we've realized is that some of the senior most developers find productivity loss because they can make it faster than actually depending on a co-pilot or so on, right? And also the junior most developers, because they are doing usually tasks which are simpler, it's also lesser. But I think it's the mid developers, people having 5 to 7 years of development expertise, who are seeing a significant uptick in terms of performance. So that's one area where we are doing a lot of internal piece of things. The second obvious thing is knowledge management, and looking at back office functions, whether it's HR, finance, legal, and RevRec and so on, where we also are seeing very strong applicability of making our efforts more and more efficient. So I think those are the two places where we are applying it.
Great, thanks. Ali, you clearly
pass it on to, I spoke a lot last time.
No, that's okay.
I forfeit my.
I want to ask you about, given the layer you are at, the hyperscale layer, and the services that you are launching, the enablement of cloud to many vertical industries, has that process changed as a result of AI?
Could you repeat the question?
Yeah, so you're enabling the cloud capability for a number of industries, and it's generally a journey in terms of how you integrate with them, how the data, you organize the data for them. So has the process of enablement of industries for cloud and other services changed as a result of AI?
I think it's refined in the sense that we're more conscious that data is even more important now. Mm-hmm. Quality data tends to be more important today than it was even in the past.
Yeah.
A lot of projects could get away with less clean data, mm-hmm. less quality data. Mm-hmm. Now the data has to be more carefully curated, de-biased, and we need to make sure that there's no garbage in, garbage out.
Yeah.
So I'd say that's one of the important impacts, is the nature of data. The other is the issue of privacy. I think the last panel was around healthcare. One of the key things in healthcare is differential privacy. And in order to ensure privacy, in many cases, where did the model get its data from?
Yeah.
Somehow this is better. Thank you. Oh, nice. Keep doing that. So when we get quality data, we have better models.
Yeah.
We have less tendency to hallucinate.
Yeah.
But the key thing is, if the model wasn't high quality to begin with, there were certain things in the news about certain vendors' models that when they were trained on, they didn't really know where the training was coming from. And it was actually trained on very not business-driven data, let me put it that way, mm-hmm. and the outcome that the model generated in those specific languages mm-hmm. Were extremely unprofessional, let me put it that way mildly. Yeah. So these models really need good data, they need governance, and the differential privacy comes from the fact that once you get that quality data, maybe you can't actually expose the data to the model mm-hmm. because it then exposes people. Yeah. We don't want that. So you then have to think about generating synthetic data that mimics the distribution of the data that you have that was quality data. Yeah. So this opens up the market for synthetic data generation, using GANs, general adversarial networks and the like. So that's an area that I think is important.
And Andrea, Accenture reported like $1 billion in Gen AI revenues. could you give us some insights into which industries are we are seeing traction, and what functions are you using AI for?
Yeah, definitely. Is this on? This one? We'll switch. Okay, we'll just musical mics. That's fine. We can roll with it. So I would actually like to add a little bit more to what Ali said around Google products, though. It's my primary job all day to work with our clients to understand how Google products are going to enable Gen AI. Sure. And from a data cleansing point and security point, 1,000%. And one of the things that we have been really impressed with as a partner organization with Google is the legacy of Vertex AI, which is their machine learning platform. It's been in the market many years now, much longer than something like ChatGPT. And a huge component of the underlying functioning of that platform is to scale the ability to do machine learning across an organization. And some of that underlying key functionality is driven by Gen AI behind the scenes. It's a low-code, no-code platform where you can type in SQL and it turns it into Python on the back end. So think about how that changes the scalability of AI across an organization for companies, and also just the cost of resources, the need to invest in resources that are experts in a particular area. It also auto-generates and suggests different model types for you. So again, supervision is required across all things, especially AI, but the ability to change the makeup of teams and create a scalable workforce that is enabled by Gen AI is really game-changing, I think, specifically because of the Vertex AI platform. And then the other area where I think Google's really leading in this space, beyond model generation, obviously, is creating these composable frameworks within their underlying data lake and data warehouse. So what that means are key components that can take you from data ingestion to dashboarding within like a month versus, 6 or 3, depending on the size of your project. And the way that is occurring is because there are now pre-coded templates. So I like to liken it to the days of, early websites when you had to hire a specialist to code in HTML. Now you have GoDaddy and you could create your own in an hour. Google's working on internal data modeling products, specifically the Cortex framework, that does that for you. So again, it's not universal, it's in early stages, it's growing very rapidly though, and so I think this is something just to be on the lookout in terms of how are we getting the right data and ensuring that it's prepared and cleaned appropriately. Some of those challenges are being addressed by Cortex itself, and then also when combined with Vertex AI, you're really getting that scaled effect.
So which industries are kind of taking advantage of it the first?
I would say we're finding success across industries, but it really comes down, I think, more than industry to size of organization, because it's expensive. And you have to be able, first of all, you need to be in the cloud, right, for compute power. Most of the very, very large organizations are, but many of the mid-sized to smaller organizations are not. So there's a barrier to entry there. But again, there's also needs to be a culture of innovation, and there really needs to be a business use case that's driven by a significant opportunity to recover ROI. And those are kind of the key factors that we see when an organization makes a decision to explore Gen AI and or advanced analytics more broadly and at scale. They're looking for, where are we going to get that ROI from? Why can't we do it with what we have today? And can we afford it, right? Is the squeeze worth the juice, right?
So from your vantage point, who are coming to you to address the hallucination and fine-tuning of the models, and where are you finding the biggest gaps, and what generally leads to that gap?
Yeah, so I think being a startup, we've started more with the mid-market and later stage startups. And I do agree that I think unlike previous waves in technology, enterprises have moved a lot faster in adopting Gen AI because they see the writing on the wall. Some of the use cases we've seen that I'm most excited about are some of the more agentic kind of use cases where it's not just, so I think there's two things that have happened. One is that just like tasks that were standard NLP tasks, like categorization, summarization, translation, the accuracy on those has just gotten a lot better. And it's become really easy to deploy those because you have like these APIs from Google, OpenAI, Anthropic, open source models, Mr. Llama, and so forth. But where things are heading is with more agentic applications where you have multi-step kind of LLM calls or calling out to tools or APIs to fetch context that's not in the base model. And there's some uncertainty there because based on what your end users ask of the system, like in a chatbot context, it can be very unpredictable. And so customers are coming to us to make their systems more robust to that kind of uncertainty, unpredictability. I think people have seen those popular popular things in the news around how the Air Canada chatbot like made up a refund policy, and then a judge said that they had to honor it. Or there was another one of a Chevy Tahoe dealership that had a chatbot, and somebody prompt injected that I want to buy a truck for $1. And so, caused some embarrassment and potential lawsuits in these kind of situations. And so, basically, those are the kind of situations where we are providing technology to help people evaluate their models before they go into production. And then as these LLM outputs are getting generated, we provide real-time evaluator models that are really customized for those use cases for these customers, so they can gate what goes to the end users and not get into these situations with lawsuits and embarrassing situations.
Got it. Now, Nitesh, you had mentioned some industries like transportation, automotive, healthcare, and as a large engineering organization or system integrator, how do you put the guardrails in different implementations in various industries based on the requirements of the industry?
Yeah, I mean, like I think a lot of the topics that have been discussed. Our go-to approach is that for each enterprise right now, I think AI needs to be centrally defined and centrally controlled. Democratizing AI in the enterprise actually often will lead to the issues that we just talked about. So I think if, because you can get then data at a central place, you can use the right kind of models on it, kind of create the harness from an observability, security, dehallucination, debiasing, all of those perspectives, and create, what we like to say, a common platform which can then, launch or make available multiple horizontal services. At the end of the day, the business logic has to sit in the product or the service which is in the business line, right? But you have to create, and we've launched this actually in the marketplace with Google, actually at Google Next. We've launched the platform of platforms, which is really that harness that we bring into the enterprise, so that you can actually bring all your data together and create those horizontal services which can power those business logic across. And that's, I think, the most relevant and the most pragmatic way to adopt AI within your enterprise. And that will also help in, expense situations. Like, so you don't have to do every product, every platform, every service does not need to have AI. So then you can use these services on an API-based mechanism into your products. So I think that's really the way we are actually trying to take this to market.
One of the things that always defines at the end of the day how technology will grow is economics. Like, is it cost effective or not, and can it scale to a point where many industries and people are adopting it? And so in relation to that, a lot of the discussion so far in the industry has been around what happens on the cloud layer. Now with launch of AI PCs and smartphones, a lot of models are running on the devices. What's your sense of how the orchestration of intelligence creation will happen, device, cloud, and the edge nodes? And is there something missing in the architecture that will really help us to take the economics out of the picture in terms of how the solutions get to the market? So Andrea or Ali, if you had any thoughts on it.
I'll start quickly just by highlighting some gaps that we're seeing in the architecture right now that are really creating these scalability into end use cases, right? And I think a lot of the value is being able to connect that unstructured data that the Gen AI models work on to your structured data. And creating that in a uniform as way as possible is kind of where the largest gap we're seeing right now is. However, again, we are starting to see some really great innovations with that. One example, we also jointly presented at Google Next on how the Cortex framework can unify data across the business. An example use case might be you have a chatbot that is interfacing with your client data, and that chatbot identifies an uptick in customer service inquiries. And there is an alert that gets sent to whoever is managing the customer service data. And by asking a couple questions of the Gemini LLM model in that instance, it can review the underlying data and tell you, oh, there's a similar product that's causing, all of these customer service complaints are because of a pedal in all of these different bikes that you produce, right? And then that allows you to go back to the underlying dashboards and search for that product or that subcomponent across all your products, identify, the part, the supplier, because all the data is in one spot, and then ask that chatbot to create an email that you could then send to clients letting them know we've identified the problem, we've sourced a new supplier, and we have a timeline when we think we can, get that information back to you. Something like this, when Gen AI is not scaled and you don't have data co-located in one place like we've been discussing, something like this can take 6 months to even, to get to that end state. It may take 2 months to even identify that there's a problem, right? So again, we're cutting down the time to business solution and giving the right tools to organizations so that they can much more quickly address customers' challenges while also, eliminating a lot of the potential costs that could come from an event like that, right?
So if I may just add quickly, I think there are a couple of things, right, to what Andre is saying. I think one important part is data preparation is key. I think the biggest problem is today everybody's going after a lot of POCs without actually creating the data foundation. And today with technology advancements, you don't have to have a data warehouse. You can pull data, to Chetan, your point, from the edge, from your structured, unstructured data. So I think data preparation is going to be very, very important. For example, right, the only reason digital twins did not succeed for 15 years, the concept has been there, is because when you go to a Boeing and you want to try and create a digital twin of a 747, the part of that is on a sketch, which was done by somebody 70 years ago, and probably it was done 120 years ago when it was first conceptualized. How do you actually first convert that into a digital data? So I think this is where I think Gen AI can really help to prepare that. And we are actually right now working very closely with NVIDIA because they have the GPU from an AI chip perspective, but what would you do if you can't enable the omniverse around it? So I think data preparation would definitely be key as we go forward to get the ROI.
I'll address the architecture question. Sorts. We have a Gen AI distributed reference architecture that you can take a look at. So it talks about how you can span from cloud to what we call Google Distributed Cloud, which you can deploy on-prem or in a data center, and you can run in disconnected mode or in partially connected mode. And then we have the on-edge version of it, which is the model called Gemini Nano. Nano mean, the small version. We also have a set of models that we call Gemma. The Gemma models are open weight models, so you can download them, take them anywhere. They're very small models. We call them baby models, very fondly. If you see them crawling around, it's Gemma crawling around. 2 billion parameters, 7 billion parameters. And we have variations of those for time series, image generation, caption generation. We have recurrent Gemma, which takes the LSTMs and recurrent neural networks, combines them with the more traditional transformer architecture. So the net of it is we can span these three architectural components in the Gen AI. We lost you. This is called failover, disaster recovery. disaster recovery fail. Thank you. That's the partnership with Google and Accenture is demonstrated right here.
Right here, right
And
here.
please give us a hand for this partnership. The key thing is that the distributed architecture allows you, from a model perspective, from an infrastructure perspective, to span these areas on device, in the data center, and in the cloud. If you have requirements that your data has to be only kept in a certain place, you can still do that. Download the models there, the models interact at that level, and then nothing is necessarily sent back. So totally feasible.
Yeah. So final question. What do you think the state of the art is in dealing with hallucinations 12 months out? And are there some blind spots you see in the industry that maybe they have not surfaced yet, but need to be addressed 12 months out?
Sure. Yeah, I think what we are most excited about is some of the literature that's coming out around steering. I think Ali mentioned it, and there's a paper from Anthropic this week where they showed that you can actually take techniques from computational neuroscience and get an understanding of what's really going on inside these large language models. And so they showed that, for example, they find this one neuron and turn the gain up on it, and then the network starts believing that it's the Golden Gate Bridge. Mm-hmm. And so, and they find millions of features like this. So I think the future is going to be, prompting is going to become more reliable. Yeah. And so at the base model level, you start getting the kind of outputs you want. But at the same time, you can use the same approaches to build better custom evaluation models. And
is it getting to a point where you can actually trace back how the hallucination occurred?
Exactly. I think it's getting there. Like, this was on a closed source model, so it was on Cloud Sonnet, so it's not available to the public. But I imagine that in the next 6 to 12 months, we'll start seeing this being applied to the open source models, so we can get better tracing back into what's really going on into these models.
Great. Well, I think we've run out of time, so please join me in thanking our panelists.